Hello everyone, welcome to day 7. Today we're going to be going over trigonometric integrals. In this section we learn how to work with different trigonometric identities when solving integrals that contain trig functions. And this is the first identity that we review. And here is another identity, the half angle or power reducing identities. And these are the product identities that we use in this section. Okay, so let's start with an example. I already started this one just by moving the coefficient to the front of the integral. And we're left with the integral of sine squared x times cosine cubed x. And the idea here is when you have either cosine or sine raised to an odd power, you're going to break it down so that you have one multiple of this multiplied by that same trig function raised to the remaining power. So for example, I'm going to break this down so then I could then use substitution and the identities. So I'm going to bring down the 14. This stays as sine squared x. And then I'm going to break this down to cosine squared x times cosine x. And then right now you're going to see why this is helpful. I'm going to be using u substitution now. And before that, before use substitution, we are going to use one of our identities, squared equals 1 minus sine squared x. And I'm going to substitute this into here, okay? So I'm going to bring everything down. Times 1 minus sine squared x times cosine x dx. And now I'm going to use u substitution. So I'm going to set my u to sine x. And then my du is going to be cosine x dx, right? And so now I could plug du here, right? And then I'm going to plug in u wherever I have sine x. So this is going to be u squared times 1 minus u squared times, well, du, right? And then now I'm going to distribute here. So this is u squared minus u to the power of 4 du. And now I can easily integrate, right? So I'm going to bring this down. This is going to be u to the power of 3 over 3. There's a multiplication there. Minus u to the power of 5 over 5. And then I'm just going to distribute the 14 now. 14 u to the power of 3 over 3 minus 14 u to the power of 5 over 5. And then I'm going to plug back in my u. Minus 14 all over, oh shoot, so sorry, this is going to be 3 and this is going to be 5. So no, this is separate. So let me just fix that. Sorry about that. Minus plus c. Okay. And so now you could see that breaking this down allowed me to use a trig identity so that I have only sines, but then I have the derivative of sine. So when I get the du, or the derivative, I am able to substitute du and easily integrate for u, right? And then plug back in sine. Okay, and so you could do the same thing with tan and secant. Here we only have tan. And this one's a little different because I don't have tan and secant. I just have tan. And this requires knowing a little bit your identities and then what are your derivatives and what are your integrals. And I know that tan squared x is equal to secant squared x minus 1. And I know that the integral of secant squared is tan x, right? Because the derivative of tan x is secant squared x. So this is easier to work with. So this is what I'm going to use here. So first let me bring the 3 to the front. And then I'm going to substitute for tan squared x. I'm going to put secant squared x minus 1 and dx. And now I could easily integrate this because I know the integral secant squared is tan x. And then this is just going to be minus x. And then everything's multiplied by 3. So it's 3 tan x minus 3x plus c. Okay, now this one's a little different. This one you could see it's multiplying two trig functions and they're both to the power of 1, right? So this one looks like the product identity that looks like this. Sine A times cosine B is equal to 1/2 of sine A minus B plus sine A plus B. And if you see these switched around, that's fine because it's an addition. So it doesn't really matter the order if this one's first or this one's first. But now let's just switch this over. So this is our A, right? Sine A. And this is going to be our B. So then I just plug everything into this new format. So this is going to be, and I'm going to bring the 5 to the front. Okay, so then this is 1/2 sine A minus B. 8 minus 5 is 3 plus sine of A plus B. 8 plus 5 is 13. Okay, and I'm going to bring the 1/2 to the front. So this will be 5/2 times the integral of sine 3x plus the integral of sine 13x. And now I could just integrate this. I know that this is going to be cosine. I mean negative cosine, right? 3x. And then I divide by 3. And then this is going to also be negative cosine 13x divided by 13. And then I bring down the 5/2. I'm just going to distribute that. So it's going to be negative 5 cosine 3x over 6 minus 5 cosine 13x over 13 plus c. Okay, let's do one more. This one we are going to use the power reducing formula. So I know that sine squared theta is equal to 1/2 1 minus cosine 2 theta. And this is what I'm going to use here. So our theta here is 2 theta, so that's what I'm going to plug in for the theta, okay? So this is going to be equal to, and I'm integrating from 0 to pi over 4. So this is going to be 1/2 times 1 minus cosine 2 theta. Here it's 2 theta. D theta, right? I'm going to bring the 1/2 to the front. And I'm left with this, cosine 4 theta, d theta. And now I'm just going to integrate. So this is going to be theta minus sine 4 theta over 4. And we're integrating between 0 and pi over 4. Okay, so this is going to be 1/2 pi over 4 minus sine 4 times pi over 4 over 4 minus 1/2 0 minus sine 4 times 0 over 4. Okay, so now here the 4 and the 4 are going to cancel, so we're left with sine pi. But so this 1/2 times pi over 4 is pi over 8 minus sine pi. Sine pi is 0, so 0 over 4 minus 1/2 times 0 is 0 minus sine 4 times 0, sine 0 over 4. Again, sine 0 is 0. So you just have pi over 8 minus all these zeros, which is going to be pi over 8 plus. Oh, wait, not plus c, because this is a definite integral. And then that's our answer. And I'll see you all tomorrow.